In this video, you will learn how to create and edit terrain models in ideCAD. We'll define terrain boundaries with elevation points, add holes, plateaus, and subregions, and explore settings for materials, thickness, and excavation calculations. You'll also see how to refine the terrain using elevation lines and points, and how the approximate elevation of the terrain at the clicked point is taken to automatically create an elevation point. Let's continue with creating the terrain. Terrain modeling in ideCAD Architectural is one of the program's most powerful features. It allows you to integrate real-world site conditions into your model, offering significant advantages, especially in architectural and urban design projects. For this terrain modeling process, we'll be using a base drawing that includes the site layout and related elevation data. Let's start by clicking the Terrain Polygon command. The Terrain toolbar will appear. This toolbar includes various commands used to create and edit the terrain model, such as elevation point, elevation line, plateau, hole, subregion, select terrain and child entities, and get elevation from terrain. There is also a value box on the toolbar where the elevation value can be entered. Click the settings icon on the toolbar. From the dialog that opens, you can access detailed options for terrain quality, drawing settings, surface texture of terrain and child entities, dimension display preferences, and units. Now, let's begin creating a terrain model in ideCAD. Our goal is to define the terrain by assigning elevation values to each corner point. After activating the terrain command, enter an elevation value of 300 centimeters into the value box on the toolbar and click to place the first corner point. For the second point, the elevation changes. This point is lower, so enter minus 100 centimeters and click to place it. Click to place the third point with the same elevation value of minus 100 centimeters. For the fourth point, the elevation changes. Enter 300 centimeters and click to place it. Finally, return to the first point to close the shape and click. After this, the program automatically creates a closed terrain boundary and generates a sloped surface based on the elevation values provided. After defining the terrain boundaries, we notice that part of the building is embedded into the terrain. In this case, we need to make an adjustment around the building. Click on the Hole command. In the value box on the toolbar, enter the elevation value for the adjustment. We want to create a flat area at 0 elevation. Define the boundaries of the area by clicking on the corner points one by one until the closed boundary is formed. Once you click the final point to close the shape, the terrain hole is created at the specified elevation. You can define multiple holes on the terrain. You're not limited to a single adjustment area. Each hole, and even each corner point of a hole, can have a different elevation. This allows for flexible modifications across the terrain, such as defining entry zones or landscape areas. Once a hole has been created, double-click the terrain to open the Settings dialog. When you enter the terrain settings, all defined terrain elements can be viewed in the 3D Model Preview section of the dialog. This includes a list of the coordinates and elevation values for the points you've defined. Holes, elevation points, and plateau are all listed here. By selecting a specific object tab, you can adjust properties such as line type, color, and material. In the Terrain tab, the Soil Base option can be enabled to assign a thickness to the terrain that has been created. You can also customize the terrain quality from this screen. Grid lines help visualize the surface form of the terrain more clearly. This feature is especially useful for analyzing sloped or highly contoured terrains, making it easier to interpret the topography visually. One of the most important advantages of the terrain command is its ability to automatically calculate excavation volumes. Based on the defined hole areas, the program calculates the amount of soil to be excavated in cubic meters when the excavation option is enabled. If backfill is required, a separate fill calculation is also performed. These calculations are extremely useful for both cost estimation and construction planning. After making the necessary adjustments, click OK to close the Terrain Settings dialog. Since the Soil Base option was enabled, the 3D view has been updated to include the terrain thickness. Let's now explore other terrain-related commands. With the Plateau command, you can draw a specific area and assign an elevation to it. Based on the assigned elevation, the surrounding terrain and the overall surface are automatically adjusted. For example, let's assign an elevation of 500 centimeters to a small area. Click the Plateau command. Set the elevation value to 500 centimeters in the toolbar, and then define the closed area. The terrain will be reshaped automatically according to this elevation. If the plateau object is deleted, the program will automatically restore the terrain to its previous state. The subregion command creates surfaces that follow the natural slope of the terrain by automatically detecting the elevation at the clicked point. This allows slope-adaptive elements such as walkways or landscape areas to be defined without changing the overall terrain slope. Click the subregion command. Define a closed area by sequentially selecting the corner points, forming a continuous boundary. Once the last point is clicked, the subregion is generated automatically, conforming to the terrain slope. You can define multiple subregion on the terrain. You're not limited to a single adjustment area. Double-click to open the subregion settings. Here, you can adjust the line color, line type, material, and elevation. By modifying the elevation value, you can shift the surface upward or downward without changing its slope. For example, if you enter -20 centimeters as the elevation, the program lowers the entire subregion 20 centimeters below the surrounding terrain, while preserving its shape and slope. The elevation point command is used to assign elevation values to specific points on the terrain. Click on the elevation point command. Enter an elevation value into the value box on the toolbar. Click on a point in the model. The entered elevation value will be assigned to that point. The terrain will then be reshaped based on this value. This is ideal for defining localized highs or depressions in the terrain. If the elevation point is deleted, the program will automatically restore the terrain to its previous state. If the Get Elevation from Terrain option on the toolbar is enabled after activating the elevation point command, the approximate elevation of the terrain at the clicked point will be taken, and an elevation point will be created accordingly. Click the elevation point command and enable Get Elevation from Terrain. Click anywhere on the terrain surface. At the point you click, the approximate elevation of the terrain at that location will be taken, and an elevation point will be created. Let's click a few different locations to create elevation point. The terrain will be updated according to each elevation point created. The elevation line command is used to assign elevation values to specific line on the terrain. Click on the elevation line command. Deactivate Get Elevation from Terrain option. Enter an elevation value into the value box on the toolbar. To create an elevation line, first define the starting point. Click on the desired location to create the next point. If needed, you can enter a different elevation value into the value box. Click the left mouse button to continue extending the elevation line. By assigning elevation values along the defined path, you can create an elevation line that influences the terrain. Once you finish by right-clicking, the elevation line will be created, and your terrain will be reshaped based on the elevation line and the elevation values you entered. If the elevation line is deleted, the program will automatically restore the terrain to its previous state. Thus, the terrain creation step has been completed. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.